I have a few questions. Why is it whenever I create an object, say object A, and then assign object B to object A, and change either object's properties, the other object too gets altered? Also, why are variables that are located inside of functions not accessible outside of the function and is considered out of scope? Is this a feature that has been unanimously agreed upon, or is it a side effect that arises from how programming languages are built? Because even in object-oriented programming languages, where we can have public and private properties inside of classes, cannot exist as public variables inside of functions. Now, regardless of the programming language you choose, these are concepts that are unanimously agreed upon by all programming languages. To the memorizers out there, these are weird quirks that you must remember and look out for. But to those who seek understanding, welcome. I would like to introduce you to the most important data structure out there, the stack. Now, the stack is kind of like a list of items, but with one main difference, and that is the last item that gets added to the stack is always going to be the first item that gets popped off the stack. We typically refer to this as LIFO, or last in, first out. So for example, if I decided to add a variable that is located right at the bottom of the stack, I would have to remove everything else that is above it in order to remove that lower variable. And in programming languages, the first thing that gets added to the stack is the main function. And you cannot remove that main function unless every single variable and every single function that has been added after that also gets removed from the stack. Once that main function has been removed, well, we exited the program. And we can actually see this in action in a programming language like C. In C, I can create an array of 2 integers. Now, by default in C, arrays are added to the stack. We know the size of this array because it is 2 integers, so therefore it is going to take up 8 bytes. However, immediately after the array, I've created an integer variable, which will also take up 4 bytes. Now, the C programming language does not check if I went outside of the bounds of my array. So that means I can access item number 0, item number 1, or even item number 2, which does not exist. But look what happens if I decide to print out item number 2. And lo and behold, it is the integer variable that gets printed out. So we can actually get a sense of what's going on here, and that is the array has been added to the stack, and then the variable has been added to the stack. Now after that, I called the scanf function to pause the program and waiting for user input. However, as soon as I provide the user input, the entire application is going to shut down. And that's because we reached the end of the main function, and therefore the array, the variable, the scanf function all got popped off the stack, and then last but not least, the main function also got popped off the stack. Now, if I decided to create another function, and this function included variables that were declared, that function too will get added to the stack, and the variables that have been declared inside of it will get added to the stack until that function completes executing, thus resulting in the entirety of that function getting popped off the stack. This explains why we cannot access variables that are inside of a function from outside of the function. Either the variable did not exist yet, or it no longer exists, causing the requested variable to be out of scope. But what if I did not know the size of the data that I wanted to store? I mean, for example, right over here, I have an array of 2 items. What if I wanted to add a 3rd item or a 4th item? Well, unfortunately, you cannot do this inside of the stack. You see, in order for me to add items to this array, I would need to either override potentially existing variables that are located above the array, or I would need to rearrange all the variables that are located in the stack. And that's just a terrible idea because that would be very CPU intensive, which would probably make a language like C one of the slowest languages of all time and not the fastest. So what exactly is the solution? Well, we will need to use a different location in memory known as the heap. Now, the thing about the heap is that it is very chaotic and very flexible in nature. If you need more memory, all you need to do is make a system call and the operating system would hand you out more memory. So in the case of our array that only had 2 integers, we can allocate for it 8 bytes. However, if this array decided to grow, we will need to reallocate memory for it. If the memory adjacent to the array was empty, then we can just give that array the extra piece of memory. Typically, this would be double the amount of memory. However, if the memory next to the array already had data, then we will have to copy that array out of memory and place it in a separate location where there is more free space available. Because again, we cannot just make the array override any existing data that is next to it, just because it feels like that memory was maybe promised to it 3,000 years ago. And these are the laws that govern all data types equally, regardless of their shape and sizes, that were set by the programming overlords. Now, just because we've placed the array inside of the heap does not mean we're not referencing it inside of the stack. You see, if we forgot to reference the array inside of the stack and just kept it in the heap, in a non-garbage collecting programming language like C or C++, that memory would just be sitting there idle until the program stops executing, and that memory gets reclaimed again by the operating system. So in pretty much most high-level programming languages, whenever we declare a large or dynamically changing variable, it automatically gets stored in the heap and returns a pointer for that memory address. That pointer then gets stored into the stack. And this explains in the first example, when we assigned object B to object A, object B and A controlled the same object. That is because the variable itself did not contain the data, but rather it only contained the memory address of that data. And using the assignment operator just duplicated that address. And if you wanted to make a copy of that object, you would literally have to copy every single property from that object into another object. And this also explains why in object-oriented programming languages we can define a public or private property inside of the class, and therefore it is quite literally accessible throughout the entire application, unless of course if we set it as private. So in other words, public and private is actually a feature, whereas calling an out-of-scope variable is actually a pretty useful side effect. And that's pretty much how the stack and the heap work, how memory in programming languages work, and why sometimes unpredictable weird behavior can maybe sometimes make sense. Also, one important note while editing this video, I feel like I didn't emphasize enough on how different programming languages treat the stack and the heap differently, because it's not a one-to-one comparison. When I say a function gets added to the stack, I don't necessarily mean the code got added. In a programming language like JavaScript, functions get added to the stack, but as execution contexts. So it's just another way of keeping track of who's calling what. In a language like C or C#, a stack frame gets added to the stack, which is like a stack within another stack. And you also have to put into consideration how multi-threaded works, where you have multiple stacks. So in other words, don't walk away from this 6-minute video saying, well, I know everything about this stack. Anyways, I feel like I said the stack a bajillion times already, so thanks for watching, and I'll see you in the next one.